As you read through the molar volume of hydrogen lab, there's a couple of things you ought to be thinking about. So one of them is you already actually know the answer. Okay, we know that the mole of hydrogen gas, okay, is 22.4 liters at STP, but we're not going to be working at standard temperature and pressure. We're going to be working at room temperature and pressure. So we're going to have to correct for that. We're also going to have to correct for the fact that we're not actually making a mole of gas. We're just going to make a fraction of a mole, so we're going to deal with that. And as we bubble this through water, we're actually not making hydrogen gas by itself. We're making a mixture of hydrogen gas and water. So all those little details have to be dealt with. First off here is that the idea we're not going to be using a mole of magnesium. A mole of magnesium would be about 24.3 grams. And so, you can see that a whole roll of this is 25 grams, a little bit more than a mole. And we're only going to use enough because all we can measure is about 50 milliliters. So we are going to try to use about 4.5 centimeters, or maybe a little bit less, of magnesium ribbon. And you can see here the little pieces of magnesium ribbon that we have for you. So you're going to get one of those and you're going to measure it out. Now it turns out it really doesn't matter how much you have. What does matter is that you know how much you have. So we're going to measure it carefully. And remember, these kind of measurements should be something like 4.50 centimeters. Since there are lines, each line on the ruler represents 1/10 of a centimeter, then your measurements ought to go to 100ths of a centimeter. So be sure you go 2 decimal places on those. Now, we know that in the reaction, okay, we're taking magnesium metal. We're going to react with hydrochloric acid. And you can see this would be a single replacement reaction. We're going to get magnesium chloride solution and hydrogen. Now we know that hydrogen is diatomic, so this is our reaction. And the important idea here is for every 1 mole of magnesium that we use, okay, we're going to form 1 mole of hydrogen gas when we're finished. And that's a really important idea. So you should look at your calculations and be able to say, if I started with 4.5 centimeters, then how can I go from centimeters to meters, meters to grams, grams to moles, and that's moles of magnesium. And so then we're going to go from moles of magnesium to moles of hydrogen, and that's the heart of the problem. So for your sample, starting with some centimeters, you should end up with moles of hydrogen when you're finished. So this guy here, that's just metric. There's 100 centimeters in a meter. This one is important because that's going to have to be based on going back and measuring 1 meter, okay, of this ribbon and finding out how much it weighs. So that'll be done on the day of the lab. How many grams in a mole? That's the periodic table. And this heart of the problem, we can see right here that 1 mole of magnesium gives us 1 mole of hydrogen. So you need to understand each of these steps and why they work. And if we change something, you'd be able to know what to change. But that's what we're going to try to do. Next then, we want to take our gas collecting tube, a eudiometer tube, and you can see that the numbers are upside down, and that's because we are holding this upside down like a giant test tube. So the open end is up this end, and the closed end is down this end. And we want approximately 15 milliliters of our 3 molar hydrochloric acid. So it doesn't have to be exact by any means. Anywhere from 10 to 20 will work. So in this case here, I got about 17 milliliters. That would be fine. So don't waste your time trying to get exactly 15 milliliters because that's excess acid, more than you need anyway, so just don't worry about it. Then we take our little piece of magnesium. Now this was a piece of magnesium ribbon, okay, 4.5 centimeters. Okay, we folded this in half. Now when you fold it in half, don't crease it really tight because it'll break right there. So you do this, and then we take our wire and we wrap it around it. And then we can take that little piece of wire, we're going to put it into the end of our tube, so that it ends up here, just before where the numbers start. So you're going to get that above those numbers, because when you turn it upside down, you want that to be below the numbers so we can capture the big bubble of hydrogen gas. Now, before you put the wire in, okay, you should have filled this whole thing up very carefully with water. So remember, the idea here is you have acid way down in the bottom, 15 milliliters more or less of acid. And then you very carefully pour in some distilled water until this tube is absolutely full. You want it to drip a little bit, and don't worry about getting it on you, that's just water. You put it in the stopper, and maybe something you can't really see right here is that there's a hole in the stopper, okay, and that there'll be a little bubble of water that comes out the top. And that's important because you want the stopper to kind of hold the wire. So the wire is going down the edge here. It's kind of hard to see in this picture, so it's actually stuck back here somewhere. And that you don't want any bubbles in your tube except for the bubbles that form from the hydrogen. So you want to make sure all the bubbles come out. Put the stopper in, and there is a hole in the end of the stopper, and that's good because as the hydrogen gas forms, it's going to push the water out that tube. Okay, now you're going to take this whole thing, turn it upside down in a beaker, and you're going to watch for the Schlieren, and you're going to capture that size of that big bubble. Now, one of the things you are going to need in the room, okay, since we're working at room temperature and pressure, is use the little weather machine, and here's the readout. So this is for the barometer, and we're going to need that in millimeters. That's millimeters of mercury. If it's set for temperature, okay, then just press on here where it says bar, that's for barometer. And if you need to go back to temperature to get the room temperature, you just press on that. And if it happens to be in inches instead of millimeters, then you click on units, and that will change the units of what this is, what the pressure and the temperature being measured in. So bar, temp, and units till you get the information that you need. And that's pretty much ideas that you need to keep track of when you do your reaction. Now keep in mind again, we were talking about the 22.4 way in the beginning. You never use that number anywhere in the calculations until you get to the very end and you find out, okay, how did my molar volume of hydrogen compare to 22.4? So don't use the 22.4 anywhere in your calculations till the very end. Okay, good luck.